Hello there. Just quickly check how loud this is. Cool. That seems good. Okay. Welcome back to AWS Cloud Quest, Cloud Practitioner. This is a game that was put out by AWS to help teach you how to use the AWS cloud. Yeah, it's a pretty good game. It's like almost like a city builder sort of sim style game, but it mainly focuses on getting you to use AWS labs. So you can use like a version of AWS that you don't actually have to pay for, and therefore it's not as scary as using your own AWS account, which is good. So without further ado, let's go. Okay, so the way it works is this. You have these assignments you can do, and each of them build you up to some sort of qualification or what have you. And the first qualification you can get is the Cloud Practitioner, and after that, you can branch out to these other ones, but you have to pay for these other ones. I've done 10 of the Cloud Practitioner things already, and I only have 2 more things to go: auto healing and scaling applications, and highly available web applications. So I have to do these in order. So I'm going to go to auto healing and scaling applications. Help the city's gaming cafe implement auto healing servers and restrict users to a specific provisioning capacity. Okay. On completion, you will be able to determine the auto healing and scaling capabilities provided by auto scaling groups, demonstrate how to create an auto scaling group with strict resource boundaries, and demonstrate how to configure an auto scaling group to respond to a time-based event. Okay. Interesting. I admit I don't fully know what all that means, but let's go. Oops. So you can come to your little phone here, root and go, and then you get to go on a little skateboard to the place that you want to go. That's a bit more fun. This music's much better. Hi, I own the city's best gaming cafe. Thanks for answering my call for help. I'm a gamer too. How can I help? I'm not a gamer, really. Gaming parties are so hot right now, and we're allowing our users to host their own servers for various games in our cafe. We have a maximum number of Amazon EC2 instances that we allow users to provision each day, but we do not have controls to enforce this rule. Oh. That's rubbish. How can you expect them to be enforced? So we have a couple of issues. First, if an EC2 instance crashes, we have no automatic way to replace it. Second, we want users to stay within their server provisioning limits. This sounds like a perfect opportunity to use auto-scaling groups. You can set up launch templates for your users' game web servers. In those templates, you can configure the number of EC2 instances to automatically scale up or down based on demand. You can also set hard limits on the number of instances that users can provision. Oh, that sounds excellent, but we have another issue. A large party is booked from 8 to 1 a.m., 8 p.m. to 1 a.m. every Tuesday. The moment the party starts, we want servers up and ready. The moment the party ends, we want the servers to shut down. How can we ensure that the user game servers start up and shut down at specific times? Using auto-scaling groups, you can configure scheduled scaling that launches and terminates instances according to a predefined schedule. I think auto-scaling groups can work for us. Can you configure an auto-scaling group for our gaming servers? Yes. Thanks for helping us. Oh, what's this? Oh, I thought it was going to get me to solve a puzzle. So, if you've watched these before, you'll know that I'm not really a big fan of the video concepts because they're just sort of waffle on in an automated robot voice. What I find is better to do when you play this game is to skip through the diagram steps instead. So, Amazon EC2 auto-scaling helps ensure that you have the correct number of EC2 instances available to handle the load on your application. Sure. You can specify the minimum and maximum number of instances in each auto-scaling group, which helps ensure that your group doesn't go below or above these limits. Okay. If you specify a desired capacity, either when you create the group or at any time after, Amazon EC2 auto-scaling helps ensure that your group has the desired amount of instances. Okay. Isn't that just the same as the other one? Or is that you saying you roughly want 3 but no less than 2? Scheduled scaling helps you set up your own timings for scaling in and out according to predictable load changes, i.e. that bloke's party from 8 to 1, was it? Or 10 to 1? Can't remember. You can configure the auto-scaling group to, for example, increase capacity on Tuesday at 8 p.m. and decrease capacity on Wednesday at 1 a.m. Sorry, yeah, that's right. You can use dynamic scaling to define how to scale capacity in response to changing demand. Okay. Okay. In this solution, an Amazon CloudWatch alarm is configured to monitor CPU utilization greater than 70%. You can create a dynamic scaling policy to track a specific CloudWatch metric, alarm, CPU average greater than 70%, that adds servers if the alarm is invoked. Dynamic scaling policies tracker. Huh. Okay, that's cool. I presume you can probably do this through something like CloudFormation as well, which would be quite cool. In this solution, a scheduled scaling event terminates all instances in the auto-scaling group. Right. Okay. Okay. Create an Amazon EC2 auto-scaling group. This is what I'm supposed to be doing. Assign EC2 instances to the auto-scaling group. Configure an auto-scaling policy to scale down to 0 resources at 1 a.m. every day. Nice. So, the way this is supposed to work is you're supposed to start the lab and open the AWS container, console, sorry, and then go through it step by step and read everything. But one of the problems with this game is that's very boring. So what I do instead is I get a timer and I guess how long it's going to take me. And then also I should try and note down somewhere. So there's 2 things you can do, I think, which make it more fun and more interesting. One is deviate from the path that they're supposed to tell you, or just guess what they want you to do. And then the game is how many steps can you take that they want you to take without being told. And the second thing is set yourself a time limit and see if you can do it faster than that time limit to force yourself to make decisions quickly. So there's like, it feels like there's more time pressure, which makes it more fun. So try and do it off the number of steps. I'm going to say if there's 35 steps, then I'll try and get each of them done in less than a minute. So 25 minutes. Are there any lab files? Nope. Cool. And then I also need something to note down the number of consecutive steps. Where could I put that? So I could just have a little thing here. Okay. Oh. Yeah. Hang on, I'll be right back. Cool. Okay. So, let's start. Blah, blah, blah. Kill that. Auto healing and scaling applications. The top navigation bar. Let's go to EC2. Auto scaling monitors your applications. Yep. 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 Auto scaling groups, probably. Create one. What do you think this is going to be called? Game servers. Probably create a launch template. Game server template. A game server for the game cafe. And they always seem to make us use recents currently in use. Amazon Linux. They always seem to make us use Amazon Linux 2. All right, okay. I think I've gone far enough. Let's see if I got it right. Services, click EC2. Okay, so this would be one step. No. Click instances. Click the game server instance ID. Go to next steps. AWS auto scaling. Help you optimize utilization and cost efficiencies. When demand drops, AWS auto scaling will automatically remove any excess resource capacity so that you avoid overspending. That's good. For the game server instance, under public IPv4 address, click the icon to copy the provided address. Auto scaling continually monitors your applications to make sure they are operating at desired performance levels. Yeah, okay. In the new browser tab, HTTP, paste the web server public IP address that you just copied and press enter. Okay, so basically the consecutive steps so far is 0. Okay. Let's find this instance then. One running instance. Public IPv4. Cool. Well, I mean, that works. And left navigate in the instance section, choose the checkbox to select the game server. Choose actions, image and templates. Okay. So it looks like they want me to create an image. And basically what this means is you look at the details of the server that you're on, or Amazon does, and you take a snapshot of all of the files that are on there, and then you can restart the instance with all of those files, basically. And I think even it might take into account the state of your instance as well, so that you can restart it in exactly the same state it was in before. And this will be important because when we come to do a launch template, we want to use that image rather than create our own one, as I was wrongly doing. Right. Actions, images and templates. Create image. Game server image. Game server instance. Okay. In the instance section, choose the checkbox. Sorry, 1 second. Okay. Oh, here you go. Here's the explanation. And they're also saying the volume. So in case you know what that is, that's the volume of data that's attached to it. Sorry, I'll be back in just once. And I am back. Okay. So they want me to create an image. For the image, type game server. Yeah, whatever. Type regular customer game server. By default, shuts down the instance, takes snapshots in any attached volumes. Shuts down the instance of any attached volumes. Creates and registers the AMI and then reboots the instance. For sure. Scroll down to the tags. For tags, choose tag, image, and snapshots together. That's already there. Go away. in the left navigation pane under Images. Oh, did it tell me to click Create? No? Yeah, it did. Easy enough. Okay, I think that I managed to do one consecutive step there. So I'll give myself a 1. And oh, 5 minutes to be created. The game server AMI was created. Under status, review to ensure blah blah blah. Private and pending. Let's push on. I only have 16.5 minutes left. On the launch templates home, click create launch template. You can use launch templates to store launch parameters so that you do not have to specify them every time you launch an instance. For example, a launch template can contain the AMI ID, instance type, and network settings that you typically use to launch instances. Cool. In the launch template name and description section for launch template type. So that would be, let's see if it's there. It's not. Launch templates. Create a launch template. Template version description. A regular launch template for a regular game. Choose the checkbox to select provide guidance to help me. Yep. Right. Go to the next step. 5,000 launch templates per region. Damn. Scroll down to the application and OS images. Click the My MIs tab. Yeah. Is it ready to be used? Still pending. Go to the next step. Scroll down to the instance type T2 Nano. Wow, T2 Nano. That is a small game. 1 vCPU and 0.5 gigabytes of memory. Midget. That is, I'm like just time wasting now. 12p a day, apparently. Is that right? Yeah, 12p a day. On-demand Linux pricing. This would be 26p a day, roughly. Even the micro is quite small, though, to be fair. They're all pretty small. Okay. Click Create New Key Pair. Okay. So this new key pair is a... which one does it want me to do? Choose RSA. So key pairs are basically, I think they're public-private keys here. Yeah, private and public key pair. And they're long cryptographic strings that basically secure access to a server and just make sure that things are secure. RSA is one of the algorithms that's used to generate these sorts of encryptions. Do they care what sort of file? Choose the .pem. Yeah, so this allows you to access things through things like the terminal or PuTTY or whatever. So if you want to SSH into your computer, secure shell something, you can use that key, and then the traffic that you're transmitting between you and that server is encrypted using your public private key. What was I doing? Oh yeah, this one. Oh, what did they say to call it? Oh, we'll just call it game server key. Sure. That's fine. Click network settings to expand the section. For firewall security groups, probably that one. Yeah, scroll down to the bottom of the page and create the launch template. Storage volumes, resource tags. Cool. Let's see if this is ready. It is. I'm not sure it needs it, but there we go. Okay. So, here's where I take a risk and see if I can get ahead of what they want me to do. Let's reload. Take that and then say auto scaling group name is game server scaler. Version default 1. Yeah. Instance type requirements. Probably going to be that. Probably going to be 1A. No load balancer. Probably I'm going to want to add. Oh, is it going to make me set up a load balancer as well? Probably. So this launch state can be used to configure the auto-scaling and healing properties of your system. This information is used to create a new instance. Okay, that's pretty cool. Quite cool that you can do that. In the left navigation pane, click auto-scaling groups. Aha! Click create auto-scaling group. You can build scaling plans that automate how groups of different resources respond to changes in demand. And you can optimize for balance between availability and costs. Cool. So I've already done that. And I did this as well. For launch template, choose yeah. Cool. Scroll down to the bottom of the page, click next. I did that. Okay, how many steps has this been so far? 1, 2, 3. Here's an application on multiple EC2 instances. You can launch instances across multiple instance types and purchase options. By choosing combined purchase options and instance types. This is an advanced feature. Yeah, don't think that is necessary for me. 7.5 minutes left. not sure this is going to get done in the allotted time. In the chosen instance, launch options step for VPC. Choose the VPC name, yeah. For availability zones, choose both sudden names. Oh, okay. So maybe I made it 4 steps there. 1, 2, 3. No, I made it 3. Both of them. Go to the next step. Click next. Attach to a new load balancer. Choose no load balancer. Keep all other default values for VPC lattice integration options. Scroll down to health checks and go to next steps. Okay. Turn the health status of an instance by using one or more of the following. Status checks provided by Amazon EC2 to identify hardware and software issues that might impair an instance. Oh yeah, okay. Health checks provided by a load balancer, which can include custom health checks. Nice. For health check grace period, type 240. So, okay. So 4 minutes. Desired capacity 2, min. Desired capacity 2, max 4. That's not a lot of people playing servers. Okay. Choose target tracking scaling policy. I think they said 70, didn't they? Let's try that. Instance warm up. When target tracking scaling policies, you select a scaling metric, CPU utilization. Just the Amazon CloudWatch alarms that invoke the scaling policy. Calculates the scaling adjustment based on the metric and the target value. Okay, so yeah, so it looks like if you do this, then Amazon CloudWatch gets activated for you, which is nice. Target value 70, nice. For scaling policy, name it CPU utilization. Is it really called that? Scroll down to the bottom of the page and then click next, not shown. Instance maintenance policy, no policy. For rebalancing events, new instances will launch before terminating others. Don't know what that means. Click skip to review. Then click next, not shown. Yeah, okay. In the add notification steps, okay. You can be notified when Amazon EC2 auto scaling is launching or terminating the EC2 instances in your auto scaling group. You can manage notifications. Oh, this is quite cool actually, this SNS. This is like a way to text you, I think. You can like text yourself using this. But skip to review, so we skip tags. And let's see if I can get ahead of what it wants me to do now. Is it probably just going to tell me to scroll to the bottom and Actually, I'm not going to do that just in case. Yeah, I should have done. Damn. Creating it. In the auto scaling group section, click regular customer game server. Go to the next step. Check the activity tab. All right. Launching a new EC2 instance not yet in service. A user request created an auto-scaling group, changing the desired capacity from 0 to 2. Cool. Desired and actual capacity. Desired and actual capacity. Okay. You can see the history of your scaling group. If additional conditions are added, you can view which condition has caused the system to scale. Click the automatic scaling tab. Scroll down to scheduled actions. Scheduled scaling helps you set up your own scaling schedule according to predictable load changes. For example, let's say that the traffic to your web app starts to increase every week based on a predictable factor. You can configure your system to preempt this event. Okay. So that would be evaluation based on 2 days, scheduled actions. So I'll probably have to do that on the DIY. Click create scheduled action. Okay. Name Tuesday party. Desired capacity, I don't know. Second wave of regulars. Type 3. Min 3. Max 4. Every week. Every week, specific start time, choose a future day. Ah. Failed. Failed. Still close though, nearly. For specific start time, choose a future day and then type 8 in the next text. Fine. And then I suppose set end time. Nope. Cool. By default, the times that you set are coordinated. Oh, I see, because they haven't got me to do that. Because how do I just delete you? Okay, they haven't got me to do that because they're going to make me shut them down every day at 1. So let's do that. So you set a universal coordinated time. When specifying a recurring schedule with a cron expression using the AWS CLI or an SDK, you can change the time zone to correspond to your local time or a time zone from another part of the network. That's cool. In the scheduled actions section, review the scheduled action. Yeah, congratulations, you've completed. Wow, there we go. Is that it? Yeah. Cool. So the DIY is configure an auto-scaling policy to scale down to 0 resources at 1 AM every day. A service will validate It's going to just start at 1 AM every day. There should be no set end time for the action. The action should run daily. Isn't that just going to scale straight back up to 2 though? And desired capacity 0, 0. Occurrence every day 1, and it is going to be tomorrow. See if that works. Auto scaling group name, scheduled action name. The auto scaling group is called the game server scaler. Okay. Right, here we go. Good to turn the sound on for the rewards. Thanks, this is just what we needed. Now choose a reward. Hellscape number 1. Hellscape number 2. What is on top of that? Let's go for that. Lovely. There we go. Level 8 builder. It was okay. I think one of the issues with these things is they don't go far enough. It would probably be better if they went further. So consecutive steps. I actually normally time myself on the DIY, but that was so easy. There was basically no point. Yeah, what's this? A spider. A spider pet. Weird. Which Amazon EC2 pricing model adjusts based on supply and demand of EC2 instances. This one. Yes. Dr. Web is becoming more friendly. Alright. So you actually have to try to get some of these pets. Let me zoom out a bit, dream view. Can I move around? Dream view, no. I built that. I see. I mean, that is cooler. How many points do I have? Nah. So what I want to do is do the final mission. So all that's left now is highly available web applications. Help the travel agency create a highly available web application. Amazon EC2, Amazon EC2 auto scaling, Amazon S3 elastic load balancing. On completion, you will be able to identify the principles for architecting highly blah 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 blah. Oh. Yeah, no, just what? That'd be quite cool. Recertify. No thanks. But what if I click this? Oh look, so you can actually go off in lots of different directions in the actual player island. That's interesting. Because this is probably what I'm looking at next. What's this? API with database, deploying RESTful APIs, serverless foundations, single page app, container services, DNS, content delivery networks, analyzing network traffic, data ingestion, backing up data, decoupling applications, resource monitoring, automation with cloud formation. Ah, yes. That's where I want to go. Oh, that's cool. What are the others? Networking. Just trying to get a look at these. It's a bit annoying that it doesn't just get rid of them. It feels like that would be an easy change. You know, just tell me I've already done it. Threat hunting, content acceleration, securing hybrid access, increase security, automate DNS querying. Yeah, anyway. Solutions architect, serverless developer. Where's that? Oh, look. Triggers, aggregating data. Use GenAI, is that? Serverless. Design a NoSQL database. So you can come in this direction. API with database. Templating a serverless application. Continuous delivery pipeline. Oh, that's interesting. I sort of want to get to some of these, you know, like the, whatever you call it one, continuous delivery pipeline. Why is that not a solutions architect? I don't care about most of these others, really. Security, maybe. Application logs, incident response, compliance enforcement, infrastructure as code. Right, so I'm interested in that. Securing your servers, secure self-service infrastructure, what? Securing a 3-tiered architecture. Security policies. Identity and access management, security policies. Lambda security, S3 security. Okay. That's pretty cool. Startup company requires rapid deployment of its IT resources for application development. The company's compliance office is a big challenge. Tracking and managing any changes to AWS resource configurations. Ah, I see. And then for the solutions architect, we've got let's move it around. Will these move it around? No. There's another easy win. Yeah, cloud formation. Okay. Anyway. Let's finish off this one. Root and go. It's interesting doing that auto scaling stuff. I wonder if it's really necessary when you're starting out building something. Yeah. Possibly not. Hi, thank you for answering our request for help. Our travel agency just had a disastrous promotional event. Oh, I'm sorry to hear that. What happened? The promotional event we held last week increased our web traffic and overloaded our website. All requests were being timed out. Worse than that, our EC2 instances were also hosted in an availability zone that was affected by severe storms. We were offline for hours. I'm so sorry this happened. Let's talk about how you can prevent it in the future. Okay. Oh dear. First, you can use AWS to create an auto-scaling group across multiple availability zones, ensuring that your resources aren't isolated. Second, you can create a load balancer so that network traffic is distributed equally across your servers. Okay, so if I spread instances out over multiple availability zones, would that make us 100% safe from failures? No system is 100% failure proof, but availability zones reside in geographically distinct locations, and a singular event is unlikely to affect multiple availability zones simultaneously. Got it, but how would we verify that our site is down in a different availability zone? After you spread your EC2 instances over multiple availability zones, you can attach a load balancer to your auto-scaling group to ensure high availability and elasticity. You can also monitor EC2 instance health by setting up a health check on your load balancer. This sounds promising. Can you build the system for us? Our site needs to handle the increased demand. Will you help us make our travel booking site highly available? I will. Thanks for helping. Okay. Video concepts, CloudWatch. I think I roughly know what CloudWatch is. The classic web application solution uses an AWS cloud computing infrastructure to ensure that an application is highly available. Yeah. CloudWatch, by the way, is basically a logging service, I think. It queries all your resources and helps you track what's happening with them. Amazon Route 53 provides DNS services to streamline domain management. Nice. Amazon CloudFront is used to deliver static and dynamic content. CloudFront can cache frequently accessed content to decrease latency and decrease costs. Cool. Amazon's Simple Storage Service, S3, is used to store static assets such as images and video, and these can be cached as well. Elastic load balancing is used to distribute traffic across multiple availability zones. Amazon EC2 auto-scaling groups are deployed for redundancy. Nice. AWS auto-scaling creates groups of servers that grow or shrink in capacity depending on demand. Nice. AWS auto-scaling also works directly with Amazon CloudWatch for metrics data. And with elastic load balancing to add and remove hosts for load distribution. Okay. For example, if a web server reports greater than 80% CPU utilization over a period of time, an additional web server could be quickly deployed and automatically added to the load balancer. Okay. Plan. Configure an auto-scaling group to use an application load balancer. Configure load balancer health checks for the auto-scaling group. Add a second availability zone to the auto-scaling group. Okay. Configure an auto-scaling group to include a new EC2 instance in the third availability zone. Okay. Start lab. And normally this doesn't take so long. Let's just get rid of all of these. Hopefully it'll go faster. Lab files 0. Good. can't do that. Choose the checkbox, select travel agency web service. Okay, I'll load the timer again. So once this loads, probably give myself, let's say 38 minutes to complete this. And once I've done it, that'll be it. Cloud Practitioner done. Done and dusted. Too easy. Oh, there we go. Okay. Go. To scaling group section. EC2. Auto scaling groups. Activity. No activity. Apparently. Oh no. Launched an instance. Desired capacity from 0 to 1. Automatic scaling. Predictive policies. No automatic scaling. Instance management. Lab stack. Does it show you very much? Does it really? Cool. Don't know why it wanted me to look at that, but there we go. Review the current capacity. Where's that? Sure. Desired capacity is the initial capacity, and the capacity it attempts to maintain. The auto-scaling group in this practice lab example can currently contain only one instance. Click the Instance Management tab. Okay, to review to see that there is currently one instance. Technically, this is a consecutive step. So far, 1. Yep, whatever. Got to specify at least one availability zone. In the network section, review to see that the auto-scaling group is configured with a single subnet availability zone. Details. So it was. It wants me to edit that and add US East 1B. Yes. Oh, no. Step 7. It says click edit on load balancing. Okay, maybe not. Cancel. Edit. Add new load balancer. Application load balancer. Probably. When you attach a load balancer to your auto scaling group, the load balancer registers with the group and acts as a single point of contact. Right, that's cool. So it's basically like a central IP address that then pings out requests to all the other places. For load balancer type, choose application load balancer. Yep. For load balancer scheme, choose internet facing. go to the next step. So I guess that means you have two choices with a load balancer. Sometimes if you've got an API that's used internally, like for example at AWS, they've probably got internal APIs. You might also want a load balancer for that too. But this one's pointing at the public internet. Choose the application load balancer to manage web-based applications that require HTTPS connectivity. Sure. For availability zones and subnets, choose 3 checkboxes to select all 3 availability zones. Cool. Create a target group. Can it tell me what to do? Click update. Choose. Create a target group. Keep the default. Update. It's a bit say after you enable an availability zone, the load balancer starts routing requests to the registered targets. On the left navigation pane, click security groups. Customize the traffic flow between the load balancer and the web servers. You can create new security groups that define what traffic is allowed to the load balancer and what traffic is allowed to the web servers behind the load balancer. Okay. So this is going to be a case of changing this. Or do they want me to create a new one? Oh, it said to create a new one. Oops. Load balancer security group. The security group for load balancer. Security group is no inbound rules. Maybe if I just say source all, outbound, not sure. Basic details section. For description, for VPC, yeah. Click add rule, okay. So far I'm on 1 consecutive step. Ooh. So it wants me to do HTTP. Oh, so close. So it's still only 1. For destination, choose the wait, what? Outbound. All right. Okay. I wonder what the tags are for. I bet they come in handy with something like CloudFormation when you want an overview of all your resources. Man, I'm smashing this. How long did I give myself? 38 minutes. Yeah. Choose edit inbound roles. I think I know what to do here. Nope, I'm going to say it has to come from the load balancer. You may not specify a reference group ID for an existing IPv4 CIDR rule. There we go. That's probably right. Don't want information to come from outside. Probably. Yeah. Yeah. So how many was that? 1. Type choose yet? Yeah. Okay. That's 2. 2 consecutive steps. I suppose I can just delete this as well. Nice. Navigation pane, click load balancers. Why would I want to do this? Maybe listeners and rules. Grim network map. No. Scroll down to security tab, click edit. Oh, right. I did not realize. Click save changes, go to next steps. View the message. DNS. Is that going to give me something? Hey, Unicorn Travel Agency. Sign in. About. Help. It does nothing. That's pretty cool. That's the first time I've done something like that. That's just a HTTP connection going through my load balancer. Easy as that. In a new browser tab or window address bar, paste the DNS name that you just copied and then add HTTP. The website is hosted only with HTTP. The final address should look similar to what is displayed in the screenshot example. Yeah, congratulations. You have moved the travel agency website behind an application load balancer. Woohoo! Use the DNS name to get quick feedback and view your application. If you don't see your application, be sure to check the rules in the security group. And the same browser tab at the end of the address that you just edited. By the way, 25 minutes left, easily on time. Type health. Instance blah 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 is healthy. Okay. Keep this browser tab open for additional health checks later. Okay. The default load balancer health check validates only the root path of an HTTP server. Applications generally will implement a much more robust application health check to validate server configuration and external access. You can manually verify that health checks are active on your load balancer. Okay. So I guess that's saying that the default load balancer health check, which is returning here, is not very thorough. And it might not tell you actually how healthy your website is. It just says, yeah, I mean, the server's up. Click target groups. Choose Right, okay. Wants me to review this or something. Healthy, 0, unhealthy. Still not much monitoring information. Requests, 8. Whatever. Click edit. Health check path type /health. Health check port 80, healthy threshold. Type 2. Is that what it said? Type 5. That is not a lot of time between checks. Click save changes. Default setting. Settings allow 150 seconds to pass before making an instance unhealthy. Okay. This is very fast. Unhealthy checks. Choose the checkbox. Select travel agency servers. So did it say go to auto scaling groups? Click this. Automatic scaling. Predictive scaling. Do you think it could be a life cycle hook? Load balancing. Empty if the checkbox is already chosen. If so, refresh the page. Scroll onto network. Click edit. You can now run your applications in a private subnet. You can add or remove subnets associated with the auto scaling group. Interestingly, this always seems to give you a little bit of a hint about what they want you to do, which is quite good. So if I edit this, is it saying that I should switch to private subnets only? See if that was it. For any other subnet that might be selected, choose deselect it, click update. Okay. Nearly made it. Click instances, choose the checkboxes, select lab, travel agency, web servers. 19 minutes left. Subnet ID. So a subnet is like the a network inside of a network. And in this case, you can have inside your virtual private cloud, which is a like something pretending to be physical hardware, but actually it's just logical boundaries built inside of a larger bit of hardware. You can have subnets inside of it, which are networks inside of the network. To expand the drop down, choose terminate instance. In the pop-up box not shown, click terminate. Go to the next step. Changing the subnet will not automatically cause instances to rebuild. Changing the subnet will not automatically cause instances to rebuild in the auto scaling group. Terminating the instance reduces the number of instances below the minimum. Okay. So if I kill you. If I kill you. Which could take a bit of time, which is annoying. After a few minutes, in the instances section, click the refresh icon. The instances list should show that a new instance was created. Choose the checkbox to select the new instance. Choose the checkbox. Yeah. Click the networking tab. Did we do that because it was public or something? Yeah, it's public. So we want it to be private. Did I actually change that? It was in the auto scaling group, wasn't it? I did. Yeah. Refresh. New one's been started. And it's in the private subnet. Get in. Click auto scaling groups. Choose the checkbox. Select travel agency web servers. Cool. Clear the checkbox to deselect it again and then choose the checkbox again. Click on the activity tab. Oh, just show that. Oh, look. Updating load balancers. Cool. Terminating EC2 instance. Launching a new EC2 instance. An instance was taken out of service in response to an EC2 health check indicating it has been terminated or stopped. An instance was launched in response to an unhealthy instance needing to be replaced. Cool. That's consecutive steps of 1. In the other browser tab, to refresh the health check page, click the refresh icon. Okay. Ooh. .502 bad gateway. In the message instance IXXX is healthy. The instance should be the value of the new instance. 502 bad gateway. What does that one mean again? Let's try refreshing. Nope. 15 minutes left. Is he going to fall at the last hurdle? So that's running on there. No balancers. Monitoring. Details. DNS name. Let's try. Why is that bad gateway? Huh. Terminated. Is it not ready or something? What's going on? Oh, it's initializing. Oh, bane of my life. Click auto scaling groups. Use the checkbox to select. I've already done that, I'm pretty sure. Haven't I? Span your auto scaling group across multiple availability zones, it says. Okay. Which means I'm going to come in here and put myself on the private subnet 2. I think in the DIY it said add a third availability zone, so that's probably as far as it wants me to go. Both labs should now be selected. Click update. Go to the next step. Just going to group section, choose the checkbox, select travel agency web servers. The bottom window might be empty. On the details tab, click edit. This is going to be desired capacity 2. Two. Yep. So that should now launch another instance, I suppose. Yeah. If we look, probably find that this one is in the private subnet 2 to balance it out. Yeah, already did that. Let's try this again. Ah, oh, come on. How can that still be a bad gateway? Let's try a new tab. Oh dear. The load balancer can use connection draining to complete in-flight requests made to instances that are deregistering or unhealthy before stopping traffic flow from the load balancer. The instances, choose the checkbox with the instance that corresponds. Check the networking tab. Yeah, already did that. When auto-scaling launches a new instance. In the other browser tab, to refresh the health check page, click the refresh icon, review the message. The page should load with the message instance. The instance ID value should be the value of the new instance. Did I shut down the other one? This is a highly available architecture and it only takes 30 minutes. Okay, but for some reason this won't run. So technically I have finished, but I haven't really, because this doesn't work. Time to turn to ChatGPT. When I'm trying to create using an elastic load balancer, I wonder if it's anything to do with to an auto scaling group. I get 502 bad gateway when I try and check the health of the load balancer. Ensure that the health check settings for ELB are configured correctly. Network security monitoring. Too unhealthy. Why is that? Did I skip over too quickly something? Edit the inbound rules. Okay. For type, choose HTTP. So this is the travel agency load balancer. Inbound rules. So I'm saying HTTP requests from anywhere is allowed. Then I'm also saying outbound from the load balancer destination Okay, no changes made. Auto scaling groups then. System tags. Security groups. Custom. Right. So I had to change this to Load balancer. This save rules. Bad gateway again. To add a new rule, click Add Rule. HTTP. Choose. Save rules. Click Edit. So I've already done that. To copy the provided name. Oh god, I'm going to fail this as well at this rate. Why is it 5 2? Why? So okay, I'm going to go very quiet now and try and figure this out. Did I accidentally edit these rules? Would this make it work? that also one like that? This is so frustrating. This is what happens when you leave the beaten track. So when I did that before, that did actually work. So what I did can't have been that bad. So it started failing when I went to click target groups. In the target group section, choose the checkbox to select. Click edit. Travel agency web servers. Click the networking tab. Yeah, this is when I killed all this stuff. Which makes sense. Okay, what is the health check port? Hmm. I don't think this can be it. Okay. I mean, let's see if I can get something different. So maybe this time I'll just get a... Nope, still got a bad gateway. Targets in the listed zones and subnets are available for traffic. Security. Monitoring. Wonder what happens if I just go straight to DIY. Configure an auto-scaling group to include a new EC2 instance in a third availability zone. I suppose technically I'd add this. Oops, I'd add this private subnet and update that. And then I would details, edit, change this to 3. So it's saying they're all healthy. But I may have fucked up the outbound. Potentially. I don't remember what it was. I could probably rewind my own stream though. Okay. Let's just try this again. Okay, so it works now for some reason. Do these things sometimes just take time or something, or... God, it's super frustrating. It just makes you think you've done loads of stuff wrong. Bloody wind up. Pretty sure it's all the same. Well, now I'm going to change the security group for the others and see what happens. I'm going to change you again. What if I kill? What if I kill you and I save that? Will it still work? It does. What if I kill... What if I kill you? Will it still work? Apparently so. Instance I01, whatever. Which instance would that be? Oh, actually, I wonder if we go to target groups. So 1 healthy and 2 unhealthy still. And it's these ones that aren't in the... whatever you call it. One healthy, which is in 1C. But it's got the same security group. They're all healthy. It's got to be that then. Surely. It's got to be this. It's making me so mad. Let's see if the DIY works. But it doesn't work. Why is it unhealthy? Why can they not speak? No, I can't live with this. What is the network mapping in an elastic load balancer in AWS? May as well collect my prize. This is great. Our site is back up. It's now highly available. Well, it is an issue because 2 of the things are unreachable, but Hey, Cloud Practitioner. Beast. Bam. Get lost. Yes. Okay. Okay, cool. Well, that's that then. If I figure out why it went wrong at the start of the next stream, I will explain.